Okay, so some time has passed since we last looked at these parts and what I've done with them. And the parts we have here, by the way, are the rotor for the Dynastart, and these are parts for the stator. This is the stator hub. These are all the pole pieces. Should be 12 of them. And all the screws for the pole pieces, of course. 2, 4, 6, 7, 10, 12. Okay, so they're all here, and what I've done to them is I've soaked them in a product called Evapor Rust. Actually, no, it's Metal Rescue. I've used both of the products. This was used, I used Metal Rescue on these, and they've turned out pretty good. I've also used a wire wheel to clean them up a little bit too, and I've actually taken the paint off the outside of the rotor here with the wire brush. And if we look at the inside is the steel parts. I was going to say metal, but it's pretty much all metal. The steel parts are pretty clean. There's still a little bit of rust on there, but I may give it one more go with the Metal Rescue, or I may just leave that as is, because it's come pretty clean. Now, something I have noticed is there are a few spots here where the covering has come off the wires, and I've got a varnish to touch them up, and something I have to do is clean the commutator surface, this flat surface down here where the brushes contact, and I'll maybe take a little bit of sandpaper and clean the snout down here, clean this outside of this part, and I think I'm going to put a little paint on the what is now the bare steel parts. I'm not going to paint the whole thing. I'll just use another rotor I have here as a guide. So I won't paint this surface or these surfaces in here. Of course, the inside won't be painted, but we'll put a coat of paint on it to keep it from rusting again in the near future. And I think what I'll do is I'll also just give this a little bit of a rub inside here. I used a wire wheel on a grinder to clean the rest of the rust off the outside. It was a little hard to get in some of the places with that, so I may take just a little bit of some fine sandpaper and try to remove the rest of that and clean this surface down here up, and may mask off where this surface here, where the windings are attached. I don't think they're actually electrically connected there, but I'm not sure. Anyway, I'll just clean it up and not paint this surface here where the seal goes, and the surface where the 3 screws go, just to clean it up a bit and keep it from rusting. The pole pieces, I think I'll just stand up on something, not this rotor, stand them up like that and paint them so that there's paint everywhere except on that surface where they make contact with the hub. Anyway, that's the pieces. Now, I don't have access to a sandblaster, so wasn't an option for me. I just tried the Metal Rescue and a wire brush, and I think they've cleaned up pretty well, to say the way they were. So I'm going to splash a coat of paint on these items here, not the screws, and then we can look forward to reassembling, finishing cleaning this and touching up the windings with some varnish, and then reassembling the stator. That's going to be an interesting project. Anyway, that's where we're at right now. Here we have the Dynastart rotor with a little bit of paint applied to the outside. It's not the maybe not the correct color, but anyway it cleans it up a little bit and should hopefully stop it from rusting again quite so quickly. And on the inside, you can see I spent some time with some fine sandpaper. It was, if I can grab it here, just some 180 grit. Just some 180 grit sandpaper. I tore off a piece small enough that I could reach down in there and just give the commutator a quick rub. No, I didn't keep going until I had all of it perfectly clean, because of course the more I take off, the less there is left. But anyway, that amount there of cleaning I think should be fine. And I also cleaned the center here around the outside with the sandpaper, and I'll get in there with a brush and just put a little paint on there, maybe some steel gray or something, just to cover it and keep it from rusting. And maybe we'll do some tests with an ohm meter here and see what we get. I believe that none of these, touching any of these segments with 1 lead of an ohm meter and the outer case, there should be no continuity, I believe, between any of these segments and the case. And I do believe there should be continuity between segments across from each other, but not exactly sure of that. Anyway, I'll do a little testing, I guess, and see what I find. Okay, so we have the rotor here and an ohm meter set on the 200 ohm scale, and what I'm going to do, before I stop the camera from bouncing here, is just check for continuity between the center hub of the rotor and the commutator surface. And the meter is staying at 1, which is an open circuit. If I touch the meter, the leads together, it jumps to 0.9, 0.8. So if I just move the probe around here, grab a mosquito here, the meter isn't moving. Just go around there, just check to make sure I've got contact on the center hub here. So as I go around the commutator surface, there does not appear to be any connection between the commutator and the windings and the center hub, which is, see if I touch the hub and one of the screws out here, if I can get a bare spot, you see it drops to 0.8 ohms. So that just shows that there's continuity between the center here and the screws that are holding the outside of the rotor together. So now, if we go from one commutator to another commutator, the meter shows 0.8. Go to another one. I'm keeping one probe still and moving the other one around to the other. So they're showing all the same amount of resistance. And just for comparison, I have another rotor here which started off in a little better shape. It's been off of an engine for a while, but the one I'm testing right now was very rusty. So there's 0.7, 0.7. So the resistance readings are very close, and none of them are shorted to ground. So it looks like this rotor doesn't have any open circuits or any short circuits in it. So what I'm going to do is just take some insulating varnish that I purchased at an electronics store, and I'm just going to touch up any spots where I see bare copper, like here, here, places along here, just to protect the wires. They're part of the winding, and I'll just make sure there are no bare spots down between here. Anywhere where I see bare copper that isn't the commutator, I'll just cover it with the red insulating varnish just to give it a little protection. I don't think there are any shorts. Well, I know there aren't any shorts from what I can see, at least not to ground. But we'll put some insulating varnish on to protect the wires before we test this rotor out on an engine. But it looks like this rotor's fine. I still haven't put any paint on the center here to keep it from rusting again, but I'll do that before I install it on the machine.
What we're looking at here is components of the Dynastart. The gray parts we see here are components of the stator. If you've been watching the videos, you may have seen me, well, you should have seen me actually, take these off the engine, and they were very rusty. So what I've done to remove as much of the rust as possible is soak them in a product called Metal Rescue. There's also a similar product called Evaporust, which I have used. They do a pretty good job of removing the rust. They're an alternative to sandblasting. And what I simply did was take this all apart, as you see it here, and soaked it in the liquid while I was doing something else, and I would take the components out of the solution, give them a brush with a small handheld wire brush just to help the product get the rust off, and they've turned out pretty good, I think. Maybe not as clean as sandblasting would have got them, but it is an alternative. I've added some paint to them just to protect them from corrosion while I put it back together, and maybe a little bit in its future. I haven't gone very thorough with the paint. The paint isn't as thick as it could be. There are some spots where it does look thin, but it's a coating to prevent rust coming back quickly anyway, I hope. Now I have left some spots without paint, spots here where the brushes will be attached, and where the screws go through the hub to mount it to the engine. There will have to be contact between this hub and the engine, I assume, so I actually masked those areas off, and I did not put paint where the seal will go. The pole pieces I painted everywhere but the bottom surface where it will contact the hub. And the screws, I put a little bit of paint on their heads, but anyway, that cleans them up. And when the coils are ready, this will go back together. And here we see the coils from the stator for the Dynastart, and we see that some of the coils have lost the insulation wrap off them. It looks like the original material was some kind of paper, and when the stator came apart, when I took it apart, the pole pieces go in the center of these coils, and when I took them out, some of the paper has come off the windings, the coils, so I would like to protect them with something when I put it back together. And what I found doing some research online was that some other people doing similar kinds of projects had used a cloth type wrap. So what I found was a cotton strip of cotton. It's sold as a 1/4 inch bias tape. It's folded in 4, so when it's opened out it's 1 inch wide. It's cotton, so I'm told that will be absorbent, because what we want to do with that is I'm going to secure it to the windings using some instant glue, to start the end of the tape. Then I'll carefully wind the tape around the winding, each coil, sorry, and secure it at the end with the instant glue again. And then I'm going to take some epoxy, thin it with some rubbing alcohol to, I think, about the consistency of water, and then soak the windings with the epoxy to seal them so that moisture can't get in at the windings, and to help hold the cloth in position. Now we want to keep the windings and the epoxy as thin as possible so that the pole piece will still fit in the center. We don't want the pole piece to be too much of an interference fit. We don't want to distort the coils as we put this unit back together, but we want the coils to be held firmly. So I'm going to try wrapping this coil, and I think actually the coils that were on the lower half of the engine, where the engine had some water sitting in it, if you recall from the look of the rotor when it came off, we could see that there had been water sitting in this assembly. I think it's just the lower ones that have seen the worst. I may not wrap any of them that look like the wrap is in good condition. I'm hoping that the wrapping I'm doing is going to protect them at least as well as the original wrap did, but I won't disturb the original if I can help it. I actually have wrapped one of the coils already. I'm not 100% pleased with how it's turned out, so I think I'm going to undo it. I did, as I explained with this one, I simply secured the wrap at the start, then wrapped the coil in its entirety, and then secured the end of it. I think I'll redo this one and secure the wrap in more places. It's difficult because of the way the coils are to keep the material tight as you go, so I may do 2 or 3 wraps, make sure they're good and tight, secure it with glue, and continue. Anyway, that's my intent, and we'll see how it goes. Okay, so I removed the binding tape, the bias tape, sorry, from the coil, because I was not 100% happy with the way that it turned out, and I rewrapped it, and I think it turned out better. Sure, I've got the coil covered as much as possible. This is the coil we're looking at, by the way. So you can see the 2 coils next to it have some bare spots. But this is the coil I've wrapped. Now I haven't coated it with the epoxy or anything, or saturated, I should say, the cloth with epoxy. But the coil is all covered, and I used about, well, I started with a length of bias tape 24 inches long, and I had to add about 2 inches. So I think the next piece I'm going to cut will be 30 inches long to make sure I have enough in one go. And since we've got 3 coils loose here, it looks like I'll be doing this coil definitely, and possibly these coils. So I think what I will just do is continue with the loose ones. Actually, yes, I think I'll secure. I've just got all of the coils loosely tied together here with some wire ties, just to keep it from flopping around and possibly getting damaged while I'm working with them. So I think now that this one is done, I'll secure it and the one beside it, and work on the one that's loose here, and then continue on. Anyway, that's one of them wrapped anyway. I will, when I go to soak them with the epoxy mixture. I'll probably do them one at a time, just to make handling it a lot easier, and so that if I have any difficulties with one, I don't end up having to redo them all because of issues, possibly with epoxy or whatever. So we'll continue on here, and I'm just going to wrap as many as I think need to be wrapped, and then I'll come back when I have that done and before I coat anything with epoxy. So I've made some progress wrapping these coils with the bias tape, and I've been trying the pole piece in the center of the windings as I go, the coils as I go, sorry, and looks like I'm not putting too much of the bias tape on, so I'm going to try soaking one of the windings with epoxy and see how it turns out before I get them all done. And since I've run out of instant glue to secure them and can't go any farther with winding the cloth on the coils anyway, I thought I'd give the epoxy a shot and see how it works out. So that's what I'm up to next, and we'll see how that works. So now I wait to see how well the epoxy hardens. The package says it's got a 4 to 5 hour working time, and it sets up in how many hours? Let's see. It just says 4 to 5 hour working time. So I assume that means that after 4 to 5 hours it starts to set up. So I thinned the epoxy after I mixed it with some rubbing alcohol. Just put it in a little disposable cup here, and then used an inexpensive paintbrush to apply the thinned epoxy to the fabric on the coils. And then I took a piece of wax paper, laid across the coil, and pushed it in with the pole piece to make sure that the pole piece will fit after this is done. Hopefully the epoxy won't stick to the wax paper, but we'll see in 4 to 5 hours. As you can see, I have made some progress on the stator. I actually decided that all of the windings needed to be rewrapped, so carefully I worked on a couple at a time, removing the old wrap, the paper type wrap that was on them, and then rewrapping them with the binding tape, using instant glue to secure the end of the tape, and also using the instant glue anywhere where I had to kind of fiddle with the tape to get it in behind a winding, or when I had to reduce it from the full inch width to the 1/4 inch width for around the corners and the short strips, etc. I just tacked it with the instant glue to hold it tight, and then worked away at it. And any place where I wasn't able to hold it tight while I worked on it, I secured it with the instant glue. And then when it was each coil was completely wrapped, I took some slow setting epoxy. I found some epoxy that has a 4-hour working time. I thinned it to about the consistency of water using rubbing alcohol, and then I used a small inexpensive artist brush. I got a bunch of them because I knew I was going to do this as I went. I wasn't going to soak them all with epoxy at the same time. And I put wax paper to protect the adjacent coils as I was using the epoxy, and then once the epoxy was applied, I actually put a piece of wax paper in the center of the coil and pushed the pole piece in the middle to make sure it was going to fit when I was done. So the coils are all done. To me they look pretty good. I just used enough epoxy on the cloth not to saturate the cloth so that it's shiny, at least in most places. This one's actually shiny. I may have done that one actually twice, but the epoxy is just on there to more or less seal the cloth and to hold it in position. So they're all done, all epoxied. And one thing I found I had to do as I was doing this was I had to secure most of the coils together using wire ties as I worked on a couple of them, so that they didn't flop around. They're held together with wires and straps here, and I didn't want to stress them as I was working on them, so the coils I wasn't working on were tied together, and it looked like they've all survived. Now, when I put the coils back on the hub, it was pretty clear that they had to go on this way, because these two contacts here, each one of these contacts makes contact with two brushes. One brush goes here, one brush goes here, so those two brushes use that contact, and then these two brushes go here, here, and here, sorry, contact that. So I believe this is all correct, but before I tighten all the screws, these screws are not tight yet, I'll just confirm this configuration and the way this cable sits. I'll compare it with another stator that is off a machine, but the stator has not been disassembled, so it's in its original state. It's not clean, it's a used stator, but anyway, I know it hasn't been taken apart recently, and it was working the way it was, so I'll just confirm that the wires on it exit at the same position, because I'm sure it's important that the wires lay in a particular place relative to these three holes when this hub is mounted. I still have, as I said, yet to tighten these screws. I'll have to confirm that I have the correct brushes. There are two different styles of brushes for these Dynastarts, and I'll have to clean up all the hardware and the holders for the brushes, and these contacts actually should be cleaned up a little bit too. They're shiny where the wires for the brushes will make contact, but I'll clean them up a little more before I put this back together. Anyway, that's the stator more or less back together and cleaned up with the cloth wrap to replace the paper wrap. Anyway, it looks like this is coming together.